I graded the question just like this for the AP exam, and what they're looking for is the tagging the dy dx's. That's for the first point, and they're looking to make sure that the algebra then flows through to get that final point. Welcome to our video here for Cranky Calculus for applications of implicit differentiation. This is a really important topic for us to go over. Please like and subscribe to see more videos like this. Couple important things here for this video is identifying key characteristics of implicit differentiation. Will be asked for horizontal tangent, vertical tangent. It's important to know that for horizontal tangent, if the dy dx is equal to 0, we have a horizontal tangent. If the dy dx is undefined or in that form of h of xy over 0, we're going to have a vertical tangent. Otherwise, if we have a 0 in the numerator and the denominator, the curve will cross itself. So let's start with this problem right here. We have L is the curve of y squared equals x squared minus 3x plus 2. So let's get rocking and rolling on this question. So the first thing I'm going to do here is read the whole question. Find the coordinate points where L has a horizontal tangent and a vertical tangent. So I'm going to real quickly differentiate this. So I'm going to end up with 2y dy over dx equals 3x squared minus 3. And then if I divide both sides by that 2y, my dy dx is equal to 3x squared minus 3 all over 2y. So I'm going to use that information here to find that horizontal tangent. So for the horizontal tangent, I need to state two things. Must state 3x squared minus 3 is equal to 0, and that 2y cannot equal 0. You have to state those two things. I'm an AP grader, and that's what they tell us. If you don't say that both of these things are true, you cannot earn both points. So with this 2y not equaling 0, that's the same thing as saying that y cannot equal 0. So that'll just help us just check towards the end here. But for this 3x squared minus 3, if I add 3 to both sides, divide by 3, I'm going to get x squared equals 1. So x is going to equal plus or minus 1. Now I do need to find these coordinate points, and that'll kind of help me out figure out what the y value is. But to find these coordinate points, I'm going to plug back into the original up here. So whenever I have x is equal to negative 1, I'm going to do y squared is equal to negative 1 cubed minus 3 times negative 1 plus 2. So I'm just plugging back into the original. And when I do that, I'm going to get y squared is equal to, that looks like a 4 to me. I'm going to get negative 1 plus 3 plus 2. So when I do this, I'm going to get y to equal plus and minus 2. And since neither of those values are 0, I'm going to get the coordinate points for a horizontal tangent. Okay with that, HT, horizontal tangent, is going to happen at negative 1, negative 2, and negative 1, comma 2. Now I checked negative 1. Let's go ahead and check x equals 1. So I'm going to plug back into that y squared equals 1 cubed minus 3 times 1 plus 2, which again, I got that from up there. And when I plug that in, I'm actually going to get y squared is equal to 0, which means that y is equal to 0, and I need to reject that x equals 1. So I only have a horizontal tangent at these 2 points. Why am I rejecting x equals 1, you ask? Because we get an output of y equals 0, which we told we cannot have. Okay, so this is the graph right over here. If I zoom out enough, this is the graph, so you can tell that I have a horizontal tangent right here, negative 1, positive 2, and right here at negative 1, negative 2. Okay, and since we rejected that x equals 1, you can clearly tell right here that we're going to cross at 1, comma 0. So now let's go ahead and find the vertical tangent. Now I know it's super obvious that you can just look right on over and see that you look at that graph, but let's go ahead and mathematically find this out. So for the vertical tangent, we are going to identify that 2y needs to equal 0 and 3x squared minus 3 cannot equal 0. What is that going to tell us? That y cannot be 0, that y can be 0, but x cannot be plus or minus 1 whenever that y equals 0 does occur. So what we're going to do is we're going to plug this back in so we can find the x values where y is 0. So we're going to get 0 squared equals x cubed minus 3x plus 2. It's the same thing as saying 0 equals x cubed minus 3x plus 2. That does not factor. So what we're going to do here is we're going to use a little bit of a cheat and know that, oh, well, y equaled 0 when x was equal to 1 from that previous problem that we just did. So we can actually factor out in x minus 1. Well, what's left? If I take out an x minus 1 and I divide it out of this x cubed minus 3x plus 2, by using long division, I can figure out what remains and I can factor it from there. You can use long division, you can use synthetic division, whatever floats your boat. For this video, I will just show you the long division. So x times what gives me x cubed? How about an x squared? Multiply that by the x minus 1, and then we're going to wrap it all together, subtract it, so x cubed minus x cubed is 0. And we don't have an x squared term, so 0 minus negative x squared is going to be a positive x squared. Drop down that 3x and that 2. And then x goes into x squared x times. So x squared minus x. Wrap that up, subtract. The x squared minus x squared is 0. And we have negative 3x minus a negative x, which is the same thing as adding an x. So we're going to get negative 2x plus 2. And then negative 2 times x gives me negative 2x. Multiply all the way through from the negative 1. Subtract that, we get a remainder of 0. So I can say that this is equivalent to x minus 1. And then my remainder there, not remainder, but my divisor there, or quotient, I'll use the right word eventually, is right there, which does factor very nicely. X minus 1, x plus 2. So this it can rewrite as x minus 1. If I can learn to write, x minus 1 squared x plus 2, which gives me an x equals 1, which I know is a no-no, and x equals negative 2. So we're going to reject this, and we're going to accept this. So we're going to have a vertical tangent, VT for vertical tangent, at negative 2 comma 0. Which if I zoom on out, you can go ahead and see that this is indeed a vertical tangent right there. We're going to keep this video rolling right along here. We have a FRQ style question. Consider the curve J defined by the equation of y cubed minus 3y squared plus 3y minus 1/4 x squared equals 0. And we're going to ask you three things. Now this question is super similar. It says it here at the bottom. My head's kind of sort of in the way, but it's a modified version of a recent there it is, a recent FRQ. And this is one that I graded. I am an AP grader, and I do know what would be accepted and what's not. So let's go ahead and go through this to see what would be accepted. So for this, show that dy dx is equal to this right here. We're going to go ahead and do that. And we're going to get 3y squared tag it minus 6y tag it plus 3 tag it. If you notice, I'm tagging all my y variables minus, this is 1/2 x equals 0. So what I'm going to do is I'm going to do two things at once. If you're okay with it, I'm going to take the first three terms and find the GCF of that, which is just the dy dx. That's all I really care about. And then I'm going to move that 1/2 x over to the other side. So I can rewrite this as dy over dx, not equals, you silly man, 3y squared minus 6y plus 3. Now I'm sure I'm going to get the question from somebody, wait a minute, couldn't you just take out a GCF of 3 as well? You could. I will in a moment. I just always like to take care of my dy dx's first. So I'm going to get dy dx equal to, we're going to divide that over so you just have the x on top. All over this 2 times 3 y squared minus 6y plus 3. Now this is totally correct, but the only thing is it does not necessarily match up. So what we're going to do here to match this up is we're going to take out a GCF of the denominator, which is a 3. And you're going to get 6 y squared minus 2y plus 1. Again, that's just from using the GCF. Now, again, I graded. a question just like this for the AP exam, and what they're looking for is the tagging the dy dx's. That's for the first point, and they're looking to make sure that the algebra then flows through to get that final point. Moving on down here to the next part, same curve. So for when x is greater than 0, y is greater than 0, there's point C on the curve J, which the line tangent to the curve is vertical. So first off, we only care about us being in quadrant 1, and that's what that's really saying for us, since x is greater than 0, y is greater than 0. Find the y-coordinate of this point where we're vertical, show that work that leads to your answer. So again, what they are looking for, they're specifically looking for you to take the denominator and set it equal to 0. This is going to earn you a point here, according to the AP exam. So the other point here that I'm going to, this time it is optional, x cannot equal 0. That's actually not necessary for this particular question, because in the prompt here, it does go ahead and say that x has to be bigger than 0. So that kind of takes away us from saying x can equal 0, but it's there. It's not a big deal to go ahead and add that information. It just is not going to get counted against you. So now when I do this, equaling 0, I'm going to factor. I believe that's going to be x minus 1, x minus 1. So you're going to get x minus 1 squared equals 0. We can divide both sides by 6. So you're going to get x minus 1 squared is equal to 0. It's very clear that y is equal to 1. So again, as an AP grader for this problem, we're looking at, are you setting the denominator equal to 0? And is the algebra flowing correctly to get that answer of y equals 1? For this last part of this prompt in these notes, we have a particle moves along a curve M defined by 2xy plus e to the x minus 2y equals 5. At that instant, the particle is at the point of -2, -1. dx dt is 3. Find dy dt at that instant, show the work that leads to your answer. So now we're going to have another implicit, but this one's slightly different. This actually takes us into the world of related rates, because we're relating everything to time. So instead of tagging dy dx, we're going to be tagging with dt's. So dy dt and dx dt. So now we're starting to tag everything. So first thing we're going to do here is find this derivative. Let's go ahead and do this in red. So be careful for this implicit differentiation, because we do have some product rule here. I'll put a p there for product, and we do have some chain going on here for that e. So for that first product rule right there, we're going to get 2 times derivative of x with respect to t is 2 dx dt times y plus 2x tag dy dt plus the derivative of any e function is just e to the x minus 2y. Take the derivative of the inside, which we have to tag dx over dt minus 2 dy over dt equals derivative of 5 is just going to be a big old fat 0 there. So now at this point, that's the calculus, that's the heavy lifting. We're now going to use our algebra skills here. So we're going to substitute out x for a -2, we'll substitute out y for a -1, and we know that dx dt is equal to 3. That's going to leave it with only the dy dt term in here, and then we just got to use some algebra and figure it all out. So this is going to turn into 2 times dx dt, which is 3, times y, which is -1, plus 2 times x, which is -2. dy dt stays there. That is my variable I'm solving for, plus this becomes e to the 2 minus 2 times y, which is a -1, which really turns into a sorry, there should be a -2 right there, plus 2. That'll make it much easier. And then dx dt is 3 minus 2 times dy dt. Now for this e term, actually no, I'm getting ahead of myself. 2 times 3 times -1 is -6. And then minus 4 dy dt. This e term right here, now I'm ready for it. This is really e to the 0, which is 1, so that kind of just vanishes in front of my factor here. So I'm going to just distribute that 1 all the way through. I'm going to get plus 3 minus 2 dy dt equals 0. Let's go ahead and collect everything. I'm going to get -3 minus 6 dy dt equals 0. Let's throw that 3 on the other side. -6 dy over dt equals 3. Divide both sides by -6. I'm going to get dy over dt is equal to -1/2. And that is going to wrap up our video here. Do not forget to like and subscribe.